Okay, now that we've talked about how to write equations in order to help us solve real-world problems, and we've talked a little bit about how to solve equations using addition, subtraction, multiplication, and division. Now we need to also be able to familiarize ourselves with equations in two variables or two variable equations. So our objective for today in 7.4 is that I can write a two variable equation in order to solve a real world problem. So first let's talk about what an equation in two variables is. An equation in two variables represents two quantities or amounts that change in relationship to one another. For example, if we have 3x equals y, that would be a two variable equation that has two quantities, x and y, that will change in relationship to one another. Or another example would be x minus 5 equals y. In both examples, notice that the x is on the side with the operation, and the y is always our solution. Okay, let's talk about a solution in two variables. A solution in two variables is an ordered pair that makes an equation true. Okay, let's review a little bit. We talked a little bit, very briefly, in one of our last chapters when we talked about integers, which are positive and negative numbers. We talked a little bit about the coordinate plane, not very much. And we talked about on a coordinate plane, we have ordered pairs that give us coordinates, kind of like playing Battleship. Okay, and in those coordinates, the values tell us where to plot a point on a coordinate plane or a grid that looks like this. Okay, so with a solution in two variables, our answer creates an ordered pair. For example, if we had the equation 3x equals y, if our ordered pair was 2, or in other words, if my x-coordinate, remember my x-coordinate is always the number on the left, and my y-coordinate is always the number on the right. So if my x-coordinate is 2, so if I plug a 2 in for x in my equation, 3 times 2 is my outcome, or my y would be 6. Let's try another one. If my x value is 3, then my y value is going to be what? 9. So my other ordered pair would be a 9. Remember, so if this is my x and my y, this is my x-axis and this is my y-axis. So if I have 3, 9, I would go on my x-axis to the right, positive 3, 1, 2, 3, and then up a positive 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I would have to plot a point somewhere up here, would represent the location 3, 9, or the ordered pair. So a solution in two variables is just an ordered pair. This is an ordered pair that makes an equation true. Okay, this ordered pair makes this equation right here a true statement. Independent variable. What is an independent variable? Well, what does that word independent mean? Well, the word independent means to be, free, or to be able to do things on your own without relying on anyone else. So an independent variable is the quantity that can change freely. it's always the x in the ordered pair. So if I'm looking at an equation in two variables, my independent variable is always my x. Okay, it's the value that is in the operation of the problem that I can change freely. Okay, it has no impact. Okay, I can always change it and make it whatever number that I want. So if I made my x value a 2, okay, I can do that. I could make the x value a 3 if I wanted, or a 4 if I wanted, and it will not have any impact on this side. I can change it freely, but it will change what my outcome is over here. So it's the quantity that can change freely. It's always my x in the ordered pair. So this one right here. The dependent variable is the value that depends on the value of the independent variable. It is always the y in the ordered pair. For example, in the two-variable equation 3x equals y, this is my dependent variable because it depends on what number you put in for x will determine your value for y. So remember, my y is always my second number in an ordered pair. So in this case, it would be 6. All right, let's turn to the back page. If we look at this graph, it says, key idea, tables, graphs, and equations. You can use tables and graphs to represent equations in two variables. The table and graph below represent the equation y equals x plus 2. So let's take a look. On this table, we have been given the values for my x, or independent variable. Remember, my x is right here, and my x always comes first in an ordered pair. Okay, so if I have a 1 in place of x right here, we would have 1 plus 2 equals 3, which is my dependent variable, my y value. So my ordered pair, if I was to make an ordered pair for this equation, I would have, in parentheses, 1 for my x coordinate, or my x value, and then a 3 as my y value. Okay, if I put a 2 where the x is, 2 plus 2 is 4. So my x, or my independent variable, would be a 2, and my dependent variable would be a 4. If 3 is my independent variable, plus 2 is 5. So 3 is my x, and y is 5. If I wanted to graph these ordered pairs, I would look on my grid. This is one square, quadrant 1 of a coordinate plane, and I would go, my x value is a positive 1, so over 1, and up y, my y value is a positive 3, so 1, 2, 3, there it is. If I wanted to graph 2, 4, I would go to the right 2 on my x-axis, 1, 2, and then on my y-axis, I would go up 4. So 1, 2, and then 1, 2, 3, 4, right there. Now 3, 5. So my x value is a 3, 1, 2, 3, and my y value is a 5, 1, 2, 3, 4, 5, right there. So now I can see the relationship of my equation. As the x value increases by 1, the y value increases by 2. So no matter what the x value is, the y value will always be 2 more than the x value. So let's pause and try, okay? Using the equation y equals 2x, complete the table that shows the relationship between the independent variable x and the dependent variable y. So if my x is 1, then what would my y be if my equation is y equals 2x? So you're going to figure out what would be the y, or the outcome, if your x is 1. And then you're going to put your answer for your dependent variable in the box and in the ordered pair in the y spot. Okay, see if you can finish this table on your own. And then what is happening to the independent variable each time? I want you to pause and try that on your own. Okay, so let's see if we can apply this to a real world situation. If you go to Yogurtland to get a treat, the ice cream costs $4 and each additional topping is 25 cents each. Write an equation using two variables that you could use to find the total cost of your ice cream. So let's think about this. What is your independent variable that will change freely in this case? Well, we know that what is going to change is our x. The independent variable is the one that changes freely, or our x. So what is going to be changing in our situation? Well, it depends on the amount of toppings. So the x is going to be changing, and in this problem, your x represents the number of toppings. What is your dependent variable that will change in relation to your independent variable? Well, we know that our dependent variable is always the y. And in this situation, what does the dependent variable represent? It represents the total cost. Okay, so let's look at an equation here. We can make an equation for, because the ice cream costs $4 plus 25 cents for every topping, which is x, we don't know how many toppings we got, equals y. Okay, so now when we're solving, we will be plugging in numbers or values for our independent variable, and depending on how many toppings you got, the price of your ice cream will increase or decrease. So let's see if we can pause and try on your own. Okay, this question says the air conditioning repairman needs to come fix your AC. He charges $25 for coming to your home. Then he adds an additional $20 per hour that he works on your house. Write an equation in two variables that represents the visit by the repairman. So you need to write an equation in two variables that represents this situation. If the repairman works at your home for 2 hours, write the solution in two variables using an ordered pair. So after you have written your equation, then you're going to find out, okay, if my x value is 2 hours, then my y value is going to be what? Okay, your job is to figure out what is the dependent variable, or the outcome, going to be. What will be the total cost of the visit for 2 hours? When you're done, come and check with me.